So this question talks about costs of going to a theatre, and important information. It says sports club buys 50 tickets. 10% of the tickets are for children, so work out as you go along. So 10% of 50 is 5 tickets for children. This question is worth 5 marks, so we're going to do quite a bit of work. It says 1/5 of the tickets are for the over 60s, so there's 50 tickets. So we're going to do 50 divided by 5 to find 1/5, so 10 tickets for over 50s. 60s. The remaining tickets are bought in the ratio 2 to 3. Okay, so we've got 15 tickets sold so far, so the remaining tickets, again, tell the examiners what you're doing all the time, so tell the story. So remaining tickets are 50, take away the 15 for the over 60s and the children, so that's 35, and they're in the ratio of 2 to 3 student to adult, so students to adult, 2 to 3, and so these are our totals. So there's 5 parts there. We've got 35 tickets, so we can see that we're multiplying by 7, so we multiply the ratio bits by 7, so the students 14 tickets and the adults 21 tickets. Okay, so that's worked out all the categories. Now all we need to do is the costs. So if we go back to the table, we can see that the children tickets are £13.50. There's 5 of those. So we'll need to do 5 times £13.50. And then we'll need to add on the student tickets. Well, we've worked out there's 14 students. So 14 times £14.50. And then adults £16.50, and we worked out there were 21 adults, so 21 plus £16.50, and then we have to add on the over 60s, and theirs is £15, and we decided there were 10 of those. We put that on our calculator. So 5 times £13.50 plus 14 times £14.50 excuse me, plus 21, that should be a times, so it costs 21 times £16.50 plus 10 times 15. Okay. So £767. Okay, so the total cost was £767. So again, with these kind of questions, it's worth just going through step by step and deciding what's going on, and go through each line and then work it through. Ratio, quite like this layout for ratio questions, where you're looking at the ratio parts, then look at the totals, and whatever you've put your numbers, then you can work out the multiplying factor to work for the rest of them. Okay, so here we've got a problem where we've got a necklace that's increased in value by 15% from its original price. It's now worth, so we had an original price, it increased by 15%, and it's now worth £1,380. So quite often when you get a question like this, draw out a little flow chart with a little diagram to help you see what's going on. Now if we increase by 15%, that's the same as multiplying by 1.15. Remember, percentage multipliers are very useful. So basically we had the original 100% plus the 15% extra, and we can turn that into a decimal by dividing by 100. The question wants what was the original price. So this is classically known as a reverse percentage because we've got to reverse the process, and that means we do the opposite of what we did in the middle here. So instead of times it by 1.15, we divide by 1.15, and that will give us the answer. So 1380 divided by 1.15 equals 1200. So the original price was £1,200. And we could check that works, because we could work out 15% of 1200 by doing the times by 0.15, and then we could add that to the original 1200, and we get the 1380 that was there. So again, worth checking. These reverse percentages, be careful with these, because unfortunately what some students do is they work out 15% of the 1380 and then just take it off. That's not what the 1380 represents. The 1380 is the value now. The 15% extra is on the original value. So we need to be careful with those kind of questions. Drawing the diagram sometimes helps you to see what's going on. We're going to solve this equation. We recognise it's got power 2 in there, and it's got the classic quadratic look. So this is a quadratic equation. Now, when you're solving a quadratic equation, quite often the technique we use on the foundation tier is to factorise. So we need to put it back into 2 brackets. Now it's going to be 2 brackets factorising, because there's no common factor to all these 3 terms apart from 1. 1 will go into both all these 3, but it doesn't change it. So it's going to be 2 brackets. Now, lots of techniques for doing the 2 bracket factorisation. I tend to go with this one because I can fill in what I know. I know that's x squared, I know that's positive 15, and I know these 2 have got to add to negative 8x. So I'm looking for things that multiply to make x squared. So we know that's going to be x and x, and we want things that multiply to make 15, but will add to negative 8. So because I want some adding to become negatives, and these must be negative, and we need 2 negatives to multiply to make 15, positive 15, negative times negative makes positive 15, and 8, well, we can see that it's going to be 3 and 5, because 3 5s make 15, negative 3 plus negative 5 makes negative 8. So we take what's there as one bracket, and we take what's here as the other bracket, and then we combine them together to give us our final answer. So here, for the factorising system, so that's not the final answer with a question. And the question says solve. So we can see that we factorised this into x minus 3, x minus 5 equals 0. So we've taken this equation and we've factorised it into 2 brackets. Now the solutions, well, we're trying to make this equal to 0. So when x is worth 3, that will give me 0 here. And 0 times anything will always be 0. And when x is worth 5, then this bracket will also be 0. And it doesn't matter how big this is, 0 times that will always give me 0. So we basically take the opposite of what's in the bracket to give us our solution. So here we can see that we could write x equals 3 or x equals 5. And we should check it. So if we put 5 in here, we've got 5 squared is 25, plus 15 is 40, 8 5s are 40, take them away, so 40 take away 40 is 0. Okay, so that's solving in a quadratic equation with x squared, take away 8x plus 15 equals 0. At the foundation level it will be about factorising and then looking for the solutions. We've got a sequence here, so we recognise that sequences, there's 4 types of sequences in the foundation exams. Arithmetic, where you've got an add or a takeaway going on between all the terms. Fibonacci, where the previous 2 terms added give you the next term. The geometric, where it's a multiplying pattern, that's the same multiplying factor between each term. And then you've got the quadratic sequences, where the first term difference isn't the same, but when we do the second term differences, they are. So there's 4 types of sequences you need to get familiar with, and we're going to practice those throughout these questions. So explain how you know what the next term will be. Well, let's have a look. So we always try the differences first. Yep, we can see that we're taking all 3 all the time. So explain how you know what the next term will be. Well, we basically say to get the next term, you subtract 3 from the previous term. Okay, and it then says find the nth term rule for the above sequence. Well, we're going to recognise that because it's going down in 3s, then it must be something to do with the negative 3 times table. So we know it's going to be negative 3n, and if we write out the negative 3 times table, it goes -3, -6, -9, -12. If we look at the sequence they actually wanted, 30, 27, 24, 21, and then we can recognise that to get from here to here we have to add 33, and we can see here we have to add 33. So it's always adding 33. So the final answer will be -3n plus 33. The -3 came from going down in threes, and n is just the term number. So remember, this is the first term, the second term, the third term, the fourth term. So is -21 a term in the above sequence? Well, we can either carry on going down and see what happens, or we can recognise that if the rule for the sequence gives us a whole number answer, when we solve the equation, then it will be a term in the sequence, because this reduces every term in the sequence. So some term n, that must give us an answer of -21 if it is part of the sequence. So we solve this in the standard way. So we take away 33 from both sides. So we end up with -3n is equal to, well, -21 take away -33 is -54. And so we got -3, -54. We divide those. So both negatives, so I can just do 54 divided by 3. It's 18. So yes, -21 is the 18th term. Okay, so that's a run through of an arithmetic sequence and the way to get the nth term, and to think about whether a term is part of the sequence. We can use the nth term rule and check whether it gives us a whole number answer, and if n is a whole number, then it's telling us what term the value is in the sequence. Okay, so this question wants us to complete this table, and it's told us what the function is. We can recognise it's a power 2 function, so it's a quadratic. So again, we should be asking ourselves, well, what do we expect as an answer? Well, because that says -5, we expect the graph to cross at -5 on the y-axis when x is 0, and we expect it to be a U-shape. So we're going to expect something like that. So let's have a look at how we do this. So we've got a calculator paper, so when you're substituting negatives, always put them in a bracket. So bracket -5, close bracket, squared, plus 3 times bracket, -5, close bracket, take away 5 equals. So we get an answer of 5. Okay, and then I can just go back and change using the replay button. I can just change that -5 to -4. Okay, so -1. And again, just replay, change that -4 to 3. So 1 squared is 1, 3 ones are 3, so 4 take away 5 is -1, and 2 squared is 4, 3 twos is 6, that's 10, 10 take away, that's 5. Okay, alright, so ways that we can work with this question then is we can look for the patterns to make sure we've done it right, and we can see that we've got a symmetrical pattern going on here, because these are all going up in 1s for the x values. We can see that at -5, -7, -7, -5, -1, -1, 5, 5. So it looks like it's going to be the correct thing. So it's asking us to draw the graph. It's given us no scale. So this is one of those questions where they're expecting us to draw our axes label fully. So we need to go from -5 to +2, and we need to go from -7 to +5. So the difference between 5 and -7 is 12, so hopefully this has got 12 centimetres on it. So let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, yep, so okay. Alright, so coming slightly over because we need more negatives than positives, and start labelling from the bottom here. So -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. Okay, so that's where our 0 is. So I'll draw my horizontal axis. And we've got to go to -5, so 1, 2, 3, 4, 5, yep, so every 2 centimetres, about a tick mark. Okay, so 1, 2, 3, -1, -2, -3, -4, -5. Okay, so at -5 it was +5, and -1, sorry, -4 it was at -1, and -3 it was at -5, -2 it was at -7, -1 it was also at -7, 0 it was -5, and at 1 it was -1, and at 2 it was 5. Okay, now what we've got to remember is that this is a U shape, so we must remember not to draw the horizontal line straight across there. It's got to come down below. So, and it's also wanting us to draw, so we've got to try and ghost this a little bit. Okay, so that gets the marks because we've gone through every point and we're within half a centimetre of everything. So sorry, half the square of everything. That's great. Okay, so that's the graph drawn. We've got the U shape. It's quadratic as we'd expect. It says use your graph to estimate the solutions to x squared plus 3x take away 5 equals 3. Now remember, x squared plus 3x take away 5 is the original graph we've drawn. So basically it's saying when does the graph equal 3? So these are our y values. And we've got to label our graph, so y and x, otherwise we'd lose a mark. And we've got to find 3. So 3 happened there, and 3 happened there. So we come down and read off, because solve means find the x. And so I come here, and I can see from my scale it's 1.65. Okay, so x equals 1.65. Now your answers might be slightly different if you drew this graph, because it also depends on how you've drawn your curve. But as long as you show your method, the examiners have to follow through what you've done. And here I've got -4.8, so x also equals -4.8. Okay, so that's how that question would be answered. So use your graph to write down the coordinate of the turning point. Well, the turning point is always where the graph goes from one type of gradient to another. Here we can see we had a negative gradient, and here we had a positive gradient, and the turning point is where it flattens out to 0 gradient, so it's going to be this point here. And so that's got a coordinate of -1.5 and -7.6. Now notice the turning point is a line of symmetry, so basically it's got to be halfway between the two values. That gave us the flat bit here, and halfway between there is -1.5. So it says to write down the coordinate, so let's write down the coordinates of the turning point. So it's going to be -1.5, comma, -7.6. It then says write down the roots of the expression. Okay, now the roots are where the graph crosses the x-axis. So in other words, the roots happen when x squared plus 3x take away 5 equals 0. That's when the roots occur. So basically it's solving the equation x squared plus 3x take away 5 equals 0. So the graph crossed there, which is negative 4.3. And it crossed here, which for me is 1.1. Okay, so that's a nice question on quadratic graphs, and some of the things that you've got to find out about quadratic graphs, the turning points and the roots. Okay.